Our project is sewage tank monitoring system. Here we have the prototype of the project. Let's have a close look. In this close look, it is evident that we have used ultrasonic sensor and a microcontroller and a buzzer, but we have really used two ultrasonic sensors. One sensor is visible to you as it is mounted at the top, and another sensor is mounted exactly below this. So it is not visible to you, but you can see the wires over there. And we have used ESP32 as our primary microcontroller, and it is paired with a buzzer. And we'll go into the explanation or working of this project. The cut water bottle here resembles a sewage tank, and a cardboard has been cut in circular to make it look as a lid. The bottom ultrasonic sensor does the job of showing the level of sewage tank that has been filled, while the top ultrasonic sensor does the job of depicting as the status of the lid, that is whether the lid is closed or open. As a first step, the ESP32 microcontroller is programmed in such a way that it shows us the level of sewage tank that has been filled up as well as the status of the lid by gathering and processing data from ultrasonic sensors. In the next step, the ESP32 is configured to a cloud database, and here we have used IBM's cloud database and IBM's IoT platform. In this IBM IoT platform, we have created a node flow for our project, and you can see that in the picture. Here, IBM IoT node acts as a primary node which gathers the data from the hardware. The gathered data will have two distance data. So first distance data will be regarding the level of the water. Next distance data will be regarding the status of the lid. First distance depicts the distance between the level of the sewage water and the ultrasonic sensor, while the second distance depicts the distance between the ultrasonic sensor as well and the lid. So this distance is then configured to two function nodes, and which are then separately configured to UI nodes such as a gauge node. As a result, when this is deployed into a separate kernel, a new UI consisting of the gauge elements and certain other parameters gets opened in a Chrome window. We'll get to view these screens. In this screen, we can see the status of the lid, whether it is closed or open, and we can also view the sewage tank level that has been filled up in percentages. We also have deployed two buttons, ignore and email button. This ignore button is used to pause the buzzer for a duration of 15 minutes so that it doesn't cause disturbance to the people who are involved in cleaning. Also, the email button is used to send these details or statistics to the concerned authorities of municipal corporation or house owners or someone else. As you can see from the hardware that the top ultrasonic sensor continuously monitors and gathers the distance between the sensor itself as well as the lid. If the distance between the lid and the sensor is too less, it can be inferred that the lid is in a closed position. If the lid is opened, then the distance will be pointing out to some huge value, and hence it can be inferred that the lid is in open status. The same applies to the bottom sensor. The bottom sensor continuously monitors the distance between the sensor itself as well as the level of the sewage water. If the distance is too high, it can be inferred that the level is too low, whereas if the distance between the sensor itself and the level of the sewage water is too low, then the level has come up and the tank needs to be cleaned immediately. Once the sewage tank or the septic tank has filled up to a particular level, an email is automatically triggered. The email can also be manually triggered by an admin, and it looks as follows. The level of the sewage water tank and the status of the lid are two important parameters that have been gathered through this device or setup. We have also built a mobile app using MIT App Inventor so that the data can also be viewed in mobile devices. This is the code, or these are the blocks that are used to develop a mobile app, and this is a closer look at one of those blocks which has been displayed previously. This is how the mobile app looks when installed in the mobile. Ultimate benefit of this project is that large amount of sewage water tanks can be monitored using these setups, and it is possible to take immediate actions. Even the municipalities can use this setup to monitor sewage water tanks in a particular area. As a result of this, immediate contamination of sewage waters with drinking waters and accidents due to people falling in drainage water as a result of opening of lids can be avoided on a large scale. A buzzer has been used to alert the people in the surroundings whenever they come near to the sewage water tank so that they may avoid falling into it whenever the lid is opened for cleaning purposes.